Okay, hello everybody.
Hello.
My name is Tom Ferguson. I'm here as a member of the Northwest Fungus Group, and I've been asked to introduce fungi to you, and more particularly to perhaps look at more detail at the grassland fungi, in order to support the project now taking place of waxcap identification, but also through what you're doing in the city region of trying to identify and improve local wildlife sites. Because the grasslands are an important part of that biodiversity in the sub-region. And these fungi we're going to talk about can help in identifying which grasslands are most important and worth protecting. I think I should say at the start that I'm not an expert in fungi. I know a lot about fungi. I've been looking at fungi for a number of years. I joined the Northwest Fungus Group about 5 years ago, and since then I've been sort of learning from them. Some, real serious mycologists in there as well. But I know a lot about more than the average person, and I'm sure I'll be able to identify most of the things. I don't know how many are coming on the list tomorrow as well. Hopefully, we'll be able to identify maple change seed. But ultimately, fungi are a pretty difficult group in general. And it's impossible to put a name to a large number of them in the field. You really have to take them back, do various numbers of chemical microscopic tests on them. And even then, some of these guys in the Northwest Fungus Group that have been looking at fungi for a lot longer than I have, will spend a week trying to put it into something and give up renaming. And so that doesn't matter too much to us, because I think what we're really looking at are the main families, give you the idea what are we looking for when you're looking at some of the common species that we hope to find. So Jill very kindly sort of sent through to me a presentation that she prepared earlier, and it was much better than mine. I had lovely pretty pictures on it, so I'm going to use this, if that's all right.
Yeah, no,
expand a little bit on it, on fungi in general. I mean, how many of you guys are sort of are you more familiar with fungi? Do you know what they are, where they fit into things? Or starting from scratch with some of you?
I've been on a couple of fungal walks and not been able to take it.
Okay. So I'd like to expand a little bit more than in the first one. And then I prepared a presentation to look more specifically at the CHEGD fungi, which we'll define, help to identify them. And Joe and myself have brought some examples on to look at the fungi in the flesh, so to speak, and some guidebooks we're going to have a look at. So we can talk about all that at the end. So let's set the scene first of all. What have I done there? Oh. So am I using the?
Press the left and right.
Is it that one?
Press the right arrow. Oh, good.
So do I continue pressing the left and right as usual?
Yeah, I mean,
okay.
If it works, if not,
yeah, okay.
Right,
okay. Just a general warning that you need to know what you're looking at when you're dealing with fungi. A general sort of issue is just to be careful when you're dealing with fungi, and just wash your hands after. Don't eat anything. If you're handling, wash your hands. I leave forays, with young kids, quite happy in letting them pick up fungi. The warning being, just don't eat anything until you wash your hands. But with one or two exceptions, you're not going to catch any harm. Right. The first thing to say is that fungi aren't plants. They're a kingdom all their own. There are the 6 kingdoms. So the main kingdoms is plant kingdom, animal kingdom, and the fungi kingdom sit in there. And the fungi kingdom includes things like sort of lichens, yeasts, and molds. When we're talking about fungi, we start talking about sort of mushrooms and toadstools. They're used interchangeably. If you look at guidebooks, some will talk about identification of mushrooms, some talk about toadstools, some talk about mushrooms and toadstools. I tend to call fungi with the caps and the gills that we'll look at, toadstools, and reserve the word mushrooms for the particular group that we're familiar with because we eat that. The main difference between fungi and plants is that plants have chlorophyll and can photosynthesize. So they're creating all the sugars, all the stuff. But because fungi haven't got chlorophyll, they've got to obtain their food ready-made. So in some respects, the fungi kingdom is closer to the animal kingdom because they're like us and having to go out and find food. They can't create it for themselves. And structurally, there are different structure to plants in that you have long mycelial strands that are made out of chitin. So when fungi are looking for the food, it falls into three main groups. The fungi that we can call the rotters, and they're the ones that are sort of growing on the leaves, dead wood, grass, and basically eating it. But in doing so, they're getting rid of all the accumulated matter. So if you imagine leaves falling every year, they're built up and up and up. Something's getting rid of all that. And the fungi are the main component getting rid of that. So not only are fungi important in the ecological cycle in recycling, it's getting rid of additional material, waste material. As they're breaking it down, amount of the goodness in that waste is recycled. So they're recycling as well. So as part of the ecological cycle, really pretty critical. The second group are the parasites. They're the ones that give fungi a bad name, I suppose. The potato famine in Ireland last year was caused by a fungus attacking the potato plant, where fungi attack humans, they attack all sorts of things. Dutch elm disease was caused by fungus, ash dieback was caused by fungus. So they have a bad press from that point of view. But I think what we have to elaborate really is that overall fungi are absolutely essential. And the third group, the mycorrhizal fungi, they're the ones that develop an association with green plants. And ultimately, we'll speak a little more about mycorrhizal later on, but ultimately, the green plants wouldn't be here if it wasn't for the fungi working with them. So if you think of we're dependent on the green plants for our existence, the green plants are dependent on fungi for their existence, and ultimately we're dependent on fungi for our existence as well. Where and when to find them? Where will depend on where the food is. So woodlands, grasslands are important. The important thing to remember that with where is that very often it's more specific than just woodland. It's specific to a particular tree. And again, I'll pick that up again when we talk about the mycorrhiza later. Timing, when to find them. Fungi can be found in all seasons of the year, but the main fruiting season is between June and November in most years, but it's ultimately dependent on the weather. This year there was nothing until September when the first rains came. So the key features of fungi are moisture and warmth. So how to identify, this is a particular type, I suppose it's what I call it a toadstool. So if we're looking at how to identify the toadstools, they have a cap, they have a stem, and sometimes a sac at the base called a volva, sometimes they have a ring, not always. But the critical thing to remember with what we're seeing here is that this is, I suppose, equivalent to a flower in the sense this is the fruiting body of the fungus. The main bit of the fungus is at the bottom in these mycelial threads. They look a bit like roots, but not roots. The mycelium is the main bit of the fungus, little threads that mass together under the soil. And they're there all the time. So when the conditions are right, the toadstool will be produced as a fruiting body. It produces spores underneath the cap on these gills. spores are blown away in the wind, and if conditions are right, the spores will germinate where they fall. So that has a number of implications in the sense that that's a fruiting body rather than the main bit of the fungus. And the main bit of the fungus stays there and can stay there for years. If you think of some of these sort of fairy rings, particularly the ones on all the grassland, the South Downs, for example, these fairy rings some of them could be 800 meters across. The mycelium of the fungus can grow at about 50 to 70 millimeters a year. So it's been estimated that these rings are probably about 800 years old. So fungus is 800 years old. There's woodlands in America where it's been, certain sized woodlands have been found to contain, the one fungus, and the DNA has identified it as the one fungus. Because of the size of the wood, it's probably taken well over 1,000 years for that fungus to colonise the whole wood. So fungi are probably the oldest living organisms on Earth. A little more detail, if we're looking at the features to identify the fungi, we start off with where it's growing. That's the starter. What tree it's growing under, what plant it's associating with. And then we look at the specifics of the fungus itself. The cap, the colour of the cap, the texture of the cap, whether the cap has spots or fibrils on it. Then we look at the gills, the colour of the gills, how the gills are attached to the cap. Some examples of how they can attach at the right at the top, they can be to the current, they can be attached further down the gill as well. So a number of attachments. The stem may or may not have a ring. And so again, we're looking at general things like sort of colour, sort of whether there's fibrils, whether it's dry, whether it's moist, features like that. And one of the other features is smell and taste. Taste is quite an important feature. The milk caps, for example, can be important. Some taste very mild, and the rustlers are the same. Some very mild, some very acrid. So it's just one of those things that tasting is essential, and it can be a little bit unpleasant at times. There's some things that are incredibly acrid, and I hope that I know those now. I don't have to try them again. And the other thing is smell. Smell is very important. Trouble is, I don't have a very good sense of smell. Some people have a very acute sense of smell. So there's some toasts will smell like coconuts. Some smell like radishes. So there's some smell like fish. So it's a good starting point. And with one family, the Cotonearies, smell can be really quite important. So if you have a good sense of smell, that will certainly help. The trouble is, some of the smells are a bit, especially some of the tastes and whiskey are described too and wide. There's an oak caps called it's the bed bug, sort of milk cap. Now, who the hell knows what bed bugs smell like? I have no idea, but there we go, it's the bed bug milk cap. Obviously, taking photographs is an important. Photographs in themselves will never be a mechanism for finding, identifying a fungus. Some reason, but the majority, you need a lot more identification than the photograph. But it's a very useful starting point. And the slide's definitely beautiful, not photographs to have to look at. Picking, yeah, but obviously just pick what you need to pick. And so one sample to take back and identify. The whole issue of picking is it's a bit controversial, because very often fungi are picked for food. And if in places like the New Forest, and I think Epping Forest as well, picking fungi has now been banned because, sort of, I think from London and other big cities, people are coming up and they're hoovering up everything in sight, and then taking it back for the restaurateurs to pick and choose. So there's a real concern that this will denude the fungi population. It's a very interesting one because the fungus is not the fruiting body, it's the mycelium. If you're picking the fungus, the fruiting body, the fungus is still there producing. And while reproducing via the spores is important, but it's interesting in the continent, for example, where whole villages go out and pick the woodlands dry every year. Those fungi are all still coming back. So it's a controversial one. Interestingly enough, I'm diverting a bit, but one of the sites that I looked at in St Helens, a former coal tip, is now a fantastic birch woodland. And every year, large number of bolets come. They're the fungi that, like the penny buns, the porcini, delicacies. And the local Polish community have now started sort of coming up and picking these. I just think it's wonderful. This coal tip was black 30 years ago. It's now sort of culturally integrated with the local community. And I don't think them picking those is going to cause any harm to the overall population. And you learn things as well. I was out there last year and there was a couple. I said, "What have you got in your bag?" And had a look, and they had in there a fungus called turkey tail, which is incredibly tough, very common. It grows on the base of trees. One of the rots trees there. I said, "I'm going to eat that, actually." He said, "Oh no, we don't eat that. What we do is we put it into vodka and let it infuse for about 6 weeks in this rather evil smelling liquid. But every morning they add a couple of that to a glass of water and drink it as an anti-cancer cure." And if you look up, fungi like turkey tail, it does have this, and there's a lot of scientific research going on at the moment. That's where there's openings there for developing links to anti-cancer cures. One of the other important identification features of fungus is if you take the cap and leave it overnight, doesn't take that long, the spores will drop out using a spore print, and then you can take the spores and run a microscope. But interestingly, the spores sometimes bear no relationship to the colour of the gills. So spores can be white, they can be black, they can be pink, they can be various rusts, yellow. So an important identification feature as well. So a few of the easier to identify groups, we've got little waxcaps. So we've got some examples of waxcaps here as well. The phaloids or the stinkhorns, an interesting group. The milk caps, so called as you can see because of the milk that comes out from the flesh if it's cut. And the bolets. The bolets of the family are easy to identify because if you look at that carefully, you can see under the cap that instead of having gills, it had little pores, it was like a sponge. And Joe's actually brought one in and looked at. There's a bullet on the blue tray you can look at to see the difference between a gill fungus and that and a poroid fungus. So some of these identify fungi. This is probably the easiest fungus of all to identify. But I want to say a little bit about this because this is what is known as a mycorrhizal fungus. Now, it's a family, the Amanitas, along with the milk caps and the russulas, or the brittle gills, the Inocybe, the Cottonarius. These are all mycorrhizal. And what that means is that the mycelium of the fungus wraps itself around the roots of trees and green plants, and then sort of extracts from the green plant the sugars that it needs, the food, because it can't produce them. And the fungi can take about 25% of the sugars that green plants are producing. But in return, the fungus enables the green plant to increase its water uptake by at least 25%. It provides access to key elements, particularly nitrogen, phosphorus, sulfur, and iron. Now, the plant needs sulfur. It needs sulfur for the creation of the chlorophyll. It needs iron for the process of photosynthesis. And the tree can't access the iron in the soil directly. It needs the intervention of the fungus to break it down into a form the tree can actually absorb. So the bottom line is that most green plants will be unable to survive without the fungus. So it's a purely in the sort of beneficial relationship. As an example of the survival, an oak tree, when it germinates and from the acorn, and it's got the soil to get through it to produce the first little cotyledons, the green leaves above the soil that can then start photosynthesizing. If that acorn hasn't been attacked, or sort of the relationship with the fungus hasn't developed by the time the green leaves have appeared, it'll die. So the oak is what's known as an obligate relationship with the fungus, because it depends on the fungus for its very existence from the start. Some trees are less dependent. The birch is less dependent. That's why the birch is a very good colonizer, because the birch can literally move into areas without the fungus, then the fungus can catch up later. So there's all these sort of interesting relationships with fungi. The bottom line is these mycorrhizal relationships are fundamental. Nearly all green plants are dependent upon fungi to survive, but only 3% of the mycorrhizal relationships are these larger fungi that we see. The majority are known as arbuscular fungi, that they actually go inside the plant and related to it there as well. So the majority of fungi that are in the soil we can't actually see. They're absolutely minute. The ones that we see, a relatively small proportion of these ectomycorrhizal fungi. And the flyguard is probably one of the best examples. So like here, Amanthustina, it's not mycorrhizal. It'll just grow happily away, but it'll be eating the leaves. So it's one of the rotters. And we've got the waxcaps. I managed to find some parrot waxcaps this afternoon, so we can have a look at those a little bit later. But again, it's one of the easier ones to identify because it's green. It's a very unusual colour when you get to fungi. And just to mention that there are some dangerous fungi. I've been so interested in fungi for I don't know how many years, and I'd never seen a death cap until last week. And I went to all sorts of interesting places looking for fungi. And the place I saw this death cap last week was growing by the link road in the centre of St Helens. So they can crop up anywhere, and the death cap, it is a problem. Once you've eaten that, you can have a problem, because we've got in the news the Australian case, the lady there has ended up in jail. The problem with it is that after you've ingested it, you don't have any symptoms for about a day, by which time the poison's really sort of seeps into your system. And while you have an initial sort of gastric episode, that can wane. And they say, no, that's over and done with, but the fungus is doing its work, and your kidneys attack, your liver attack, and ultimately, unless it's got very, very early on, the chances are you're not going to survive eating a death cap. And very similar to the same family, the destroying angel. Yeah, lovely name. So the general is, just be careful if handling fungus. Always wash your hands. If you are going to taste test, don't do the one of it. So I won't say too much about these now, because I'll go into the presentation I've done, but really what we're on about at the moment is trying to understand these fungi, CHEGD fungi, as indicators of high quality grasslands. So I think if we move on to, you want to talk about further reading, or should we do that at the end? How do you want to?
I mean, it's just a list of books really, which we can put it back up at the end if you're interested in any books.
Yeah,
and then
do that. Okay.
Phone app, but we can put that up at the
Right.
end if people
Okay.
want list of stuff that's probably easiest.
Okay, so this little bit is to introduce you to the CHEGD fungi. Do you know what they are? Have you? This is all new. Okay, right. So what do they stand for? C stands for fungi called clavuloids, groups of fungi that, so some of the coral fungi and some of the little clubs that we see. H stands for Hygrocybe, these are the Waxcaps. E stands for the Entolomas, or the Pinkgills. G stands for the Geoglossum, the Earthtongues. And D stands for Dermoloma, another very small group. It's worth mentioning when we come to giving common things names, there's a massive amount of research going on at the moment, and a lot of reworking. It's the same in sort of, with plants as well. They're all being renamed as sort of DNA analysis is really overturning a lot of our previous assumptions. And with fungi, it was very difficult because all fungi at one stage were called, were organics. The assumption that they're all the same. And then names very often came from what they actually looked like. It's now wide open, and sort of families that we thought we were familiar with have been split up, new ones created. So the Waxcaps, it always used to be quite simple. If it was a Waxcap, it was a Hygrocybe, but they are now Cuphophyllus, Clavariaceae, Chromocera, Gloriforus, Porphyllomopsis, Neohygrocybe, and Hygrocybe.
Make any book more about unfolds.
Which is, it's an out.
But is that
Yeah.
It has got.
is that new edition?
This is the new edition.
Oh,
It changes every day. It's not. So if we're out in the field, if I call something Hygrocybe and it's not, I apologise. I can't keep up with it. When I go back and sort of do something and sort of writing it up, I'll double check then. But old habits die hard. But it's just a warning. So when we're talking about grassland habitats, obviously, they're pretty scattered. But the bottom line is that grasslands aren't climax habitats. Grasslands would become woodland unless they're managed in some way. So in rural areas like this Portland Hadrian's Wall, the main management mechanism will be sheep or cattle or something like that. So they keep the grass and maintain it as grassland. In the urban areas, the grassland sites are obviously much smaller, and there are different types of grassland, a lot of amenity grasslands, playing fields, and the likes. But from the higher quality end, some of the better grassland sites in the urban areas are churchyards and cemeteries. But ultimately, it depends. This is the one that is local to me in Eccleston and St Helens. The bottom line is that the grass is mown regularly. They mow this every week, but they take away the cuttings. So they don't enrich the soil. As soon as the soil is enriched, then the habitat for waxcaps and other fungi is weakened. And they certainly don't fertilise it to get this immaculate green lawn that seems to be so important. So these are the sorts of sites that we need to be looking at in the urban area. So what I've done, I've just given some examples now of what I think will be some of the more common species that we've every chance of seeing locally, because most of these, with one exception, I've seen in that local churchyard in St Helens. So hopefully tomorrow, this might act as a bit of an introduction. So Clavariaceae is one of the corniculata. That's again one of the clavuloids, and again it's an indication of what we haven't really said before, and focusing on the toadstool as sort of a fungus. That is just one example of the vast majority of different shapes and varieties So here we have these little coral fungi, also little club fungi, Clavariaceae fragilis. There's also two yellow ones, which are quite common, but can only be identified microscopically by looking at the spore sizes. So these aren't very big, they're not an inch high, so it's eyes to the ground with these. You got
Yeah, I've got a few.
Ah, very good.
Not that big.
There we are, very good. So the wax caps are a bit easier to spot. And the wax caps generally are really interesting in the sense that they're so colourful. And you'd expect them to be so colourful, they must be to identify. But they're not. Like another big group of the Pinkgills, the Rustroids, they're incredibly brightly coloured fungi, but incredibly difficult to identify despite being colourful. So I don't pretend that I'm able to identify everything that we find, but I could do back at base, but in the field, some little red ones are real problems. But the snowy waxcap is pretty straightforward. There is one that looks very similar to it, called Russell Hygrocybe, Russell coriaceus. It has more of a brown cap and is meant to smell of cedar wood. So if your smell's good, that's something to look out for. The trouble is, some of the snowy waxcap can start off with a sort of beige cap looking just like it. But everyone I've checked over the last few years has always turned out to be snowy waxcaps. So little white waxcaps should be pretty straightforward.
Well, there are cedar woods in spring fair tomorrow.
Oh, cool.
So
Right.
when's deodorant? I thought it smelled a bit like.
Right.
Everything.
Well, you can introduce me to that. That'd be brilliant. I'll learn a new smell. That'd be good. That'd be good. These current gills, that's an important feature with the snowy waxcap.
So that one, the girls run down the.
Yeah, right. Sorry, the desk. Now the scarlet waxcap, does that grow? I've not seen that
Yeah,
one.
we had all three big cherry red ones in sight just to the north, so.
In
Not in the cemetery, but we get scarlet splendid.
Right, that's not, yeah, that's because you don't get, some of the rural habitats either. So the scarlet waxcap is probably the commonest of the bright red waxcaps. Sometimes a yellow edge around the cap. Stem can be red or orange, and the cap moist. The stem dries. With moistness and dryness are important features with waxcaps. So it might be a moist cap or a dry stem, a moist cap and moist stem. So again, those are important features that should help direct you to the right identification. One of the little red ones, the vermilion waxcap, it has, as it dries, it has a sort of a scurvy cap. It doesn't have a smooth cap. There's little sort of sturdiness, sort of roughness to it. Doesn't always show up when it's fresh, but if you hold on to it, let it dry out, that usually comes through. So again, not an easy one because there are several little red sort of wax caps that you get. So what do you know which ones you've got in the we might be looking out for tomorrow?
Probably the commonish red ones, so we definitely get scarlet in the middle.
Right. Right.
So
Okay.
we've got one record.
Yeah, and they're quite stout. These are very small. The scarlet and the vanilla, they're quite large, quite stout fungi. Very dramatic. The blackening waxcap. This is the new Hygrocybe conica, because as you can see here, it has this conical caps. But again, another feature of fungi is that as they go through the life cycle, the features can change quite dramatically. So that will tend to open. I think we've got here.
More examples. Well, that's they both of them.
Yeah. So this is.
And that's the slightly fresher one.
Yeah. So this is something very conical, but as it's flapping, well, it does tend to retain a little pointed umbel in the centre. And as you can see, this one's going black as it ages. Again, that should be pretty easy to identify. The only one might confuse that with is one called conicoides. That grows on the sand dunes, the particular, the base of the sand dunes. That's quite unusual, but that grows up in the Sefton dunes. So again, little conical red ones, red, yellow, sometimes can be a bit orangey, conical cap, but going black. And they can go black very quickly after sort of appearing. Yeah, that's just to sort of emphasise the colour change and lose their intense colours and end up. And the little black bit that is there for quite some time. You can see sort of the remains of the waxcap long after it's dried out. This is the butter waxcap. This is quite a common one. Very small one. There is one like it, the golden waxcap, tends to be a bit bigger. And the thing to look for there is the gill attachments. The gill attachments in this are quite sort of broad and can almost become a little bit decurrent on the and it's one where the cap is quite greasy, but the stem tends to stay dry. I think we should find. I mean, you've brought some in. Yeah, I think we'll find those. This is the golden, the Chlorophana. I've not found this locally, but I'm sure maybe this site. This was taken up off Adrian's Wall. Again, quite larger, but very yellow. And then the gills basically do a bit of an upward turn as they meet the stem. So the gills are narrowly attached in that one. The meadow waxcap, not the best of slide. Again, it's a bit too orange, that slide. It tends to be a little bit more sort of paler brown, buffish colour, but a very tough waxcap, very robust, with decurrent gills again, and usually pretty dry. And the stem itself, if you look at it carefully, is fibrous. It's with fibres running down it, which is quite unusual in waxcaps. Hygrocybe irrigata, very slimy. You can impression from the photograph. I've brought in a little Hygrocybe called glutinipes, which again is another of these sort of slimy, sticky ones. And if you touch it, you can feel the stickiness. It's drying up a bit now, but just after the rains, then you can almost see the bits of stickiness dropping off the gills. It's so slimy, and the slimy waxcap a bit like that as well. One of the brown ones, but very slimy all over stem as well. This is no longer Hygrocybe. This is Portolomopsis electriformis. This is the pink waxcap. There was a time when this was thought to be an extreme rarity, and I think the National Trust organised through a national encouraging people at the sites to look for this because it's so obvious, pink. And it was turning up all over the place. So it's not quite as rare as was originally thought, but it's a good find. So I don't know if has that been turning up?
We found one on this site to the north, so we might get it.
Yeah, it hadn't appeared on my site. I've not seen it in Christchurch for about 7 or 8 years now. But again, this can happen with I've not been there every week over the fungi season for the last 10 years, so you can easily miss them. This is a problem again. So getting the season just right, and it applies not just to waxcaps, any fungus. Sort of arranging a date for fungal flora is a nightmare, because some years there might be sort of so many you can't walk around without standing on them. Other years absolutely nothing at all. So in looking at identifying sort of grasslands from the perspective of what fungi are growing there, because a fungus isn't there doesn't mean it isn't there permanently, and so the site will have to be revisited annually, and preferably several times in the season as well to accurately come to some definitive conclusion like that. This was also called the ballerina waxcap because as it sort of matures, the cap splays out and creates this sort of little sort of tooting effect as the ballerina's skirt. And finally, the parrot waxcap is no longer a Hygrocybe, it's Clavariaceae. An easy one to identify, I think, simply because it's green. Slimy again, but as it ages, and even from the start, some can be yellow. So if you look at the cap, it looks yellow. And as it matures and grows old, it can almost become white. But usually the test is, if you pick it up, turn it over, and look at the top of the stem, that nearly always remains green. That's the giveaway. So it might start looking like something else, but if it's got that green bit at the top of the stem, then you've got the parrot waxcap. So that's just a selection of the waxcaps. There are obviously more, there's 50, 60 different species, but that gives you a flavour of, hopefully, some of the ones we'll find tomorrow. The Pinkgills are an absolute nightmare. Entolomas are a problem even for the most experienced mycologists, because even when you get to the microscopic stage, the spores and the cystidia all tend to look alike. So you've got to have the highest quality equipment for measuring things to micro views. So views of thousands of a millimetre. So you're looking at sort of measurements below that level to just try and sort of get these. So I think what we're really looking for is presence or absence.
I very much do presence or absence of Entoloma.
But having said that, we should be able to identify this Pinkgill. I was in Storosporus, used to be called Storosporus, called something else now, and Ceraceum. I think I've got an example of that. Yeah, that's Ceraceum. It's called the silky Pinkgill because the cap goes nice and silkiness. And if you look underneath, the gills look white, but in practice, as it matures, they all go pink. And if I were to take a spore print of that now, the spore print would be pink as well. So that's why they call it Pinkgills. That's the giveaway. So I think we're really looking for those. There are one or two little blue ones that might come. If we find them, I'll have a go. But I'm not promising. If we get as far as finding some and identify a couple of them, that's as much as we can expect. The Earthtongues, they're not very common. The only time I've seen Geoglossum is on the Septon dunes because they do tend to prefer sandy soil. So I don't know.
There's one, the cemetery near me gets them.
Right.
And where we are tomorrow is on that big sandstone ridge around Allerton. So we might get them.
So it's on the
It
sandstone.
might be a bit early, but it's on sandstone.
Okay.
So
Well, that'd be good. Yeah, that'd be really good if we can come across. But obviously, black, dark brown to black. The only complication may be this. This is Geoglossum hirsutum. The keys in the name hirsutum, hairiness. So the stem is velvety. So that should distinguish it from the Geoglossum. But black, about the same size. These probably a little bit smaller. So we'll look closely at anything we find. And then finally, the Dermoloma. There's probably only one that we'll come across. Cuneiform. They're called crazed caps because as they mature, the caps tend to split up. You get this nice sort of patterned effect on the cap. The little grey ones with grey or white gills. A farinaceous smell. So those are the good centre smell. it's a bit flowery. That should help as well. So I think that is it, folks. I hope. So, little introduction. It's a vast subject, so I don't want to overfish you. But I think the bottom line is we can have a look. We've got an idea of roughly what we're looking at, and the more difficult ones that we find, take away and have a look back at base and trying to build up the species list. But any questions? Fire away.
I mean, we've got, so if you want to have a look at specimens, so we, Merseyside Biobank has had some funding from Natural England to run a Waxcap or CHEGD grassland project. So we're carrying out some surveys to try and find sites with good records of them. So if any of you use iNaturalist, you can record on that, and that any records you submit in the Liverpool City region area will go onto that project automatically. So when you're recording, if you do come across any recording things like Tom said, like texture, smell, all that kind of stuff helps identify, we don't expect you to identify it, but there's quite a few people on Naturalist that will identify some of the stuff. So just all the information you can in the notes if you go out recording.